Hello everyone. Today we are going to learn about the application of linear equation in two variables. In that we are going to discuss on problems which are on the speed. So it is the first part where I am going to solve only one problem based on boat and stream problem. So let us see. You should be able to know these three cases. The first one is still water. The speed of the boat will be completely depending upon the rower. So second case is downstream. Downstream in the sense here what happens, the boat and the direction of the stream, or we can say the direction of the river, both are same. Here what happens, the speed of the boat automatically increases. So next case is an upstream. So in the upstream, the direction of the boat and the direction of the river are different. Let's continue. Speed of boat and water, and this water will consider this as a stream. So we'll consider speed of the boat in still water as x km/h. Why it is still water? Because there won't be any effect of speed of water or stream on the boat. And then speed of the stream as y km/h. So let us consider this case. Consider this as a river which is flowing downstream. So that means the direction of the river is this. You can see the red line that indicates the direction of the river. Now let us take a boat. The boat is also moving in a downward direction. So this is the direction of the boat. So as we have considered, the speed of the boat is x km/h and speed of the stream is y km/h. Here what happens? Both river as well as the water or stream are in the same direction. So in this case, the speed of the boat increases. That means that it becomes the speed of the boat plus the speed of the stream. That means it becomes x plus y km/h. So let us mark it like this. Downstream is equal to x plus y km/h. Let us go to the next case. So next case you all know, that is upstream. Correct? In the upstream what happens? The direction of the river remains the same, which is downwards. But the direction of the boat changes. Means now the boat is moving against the direction of river. So here what happens? The speed reduces. That means here it becomes x minus y km/h. Okay. So now we can say that in upstream what happens? The speed becomes x minus y km/h. Okay, this you can understand by one situation. When you are riding a bicycle in the direction of the wind, you will be able to ride faster. Whereas when you are riding a bicycle against the direction of the wind, automatically what happens? You will experience an opposite force. So you will not be able to ride faster. The same thing is applicable here. But here, which is opposing us? It is river. Okay, let us start a problem. So you can see here a boat goes 12 km upstream and 40 km downstream in 8 hours. It can go 16 km upstream and 32 km downstream in the same time. Find the speed of the boat in still water and speed of stream. So we are going to use the same idea over here. Now one thing you have to understand here, the time which is given, it is 8 hours, correct? So 8 hours is not only for upstream or downstream, it is time taken for a boat to travel upstream as well as downstream together. And in the second sentence, that is, it can go 16 km upstream and 32 km downstream in the same time. That means in the second sentence also, the time taken by the boat is 8 hours itself. So let us start solving this. So I'm going to take the same picture as we have discussed before. So same cases are considered. So what is that? Speed of boat, we will take it as x km/h, stream as y km/h. We know that speed of the boat in downstream, it will be x plus y km/h because the speed increases as the direction of boat and the stream are same. And speed of boat in upstream, what happens? It becomes x minus y because the direction of boat and the river or stream are different. So let us frame the equation for this. So before starting with this, we all know this formula, that is speed is equal to distance by time, and we will rearrange this formula as time is equal to distance by speed. Why we are rearranging? Because we know that the 8 hours time is the total time taken in both upstream as well as downstream. So for that reason we are rearranging the formula as time is equal to distance by speed. So time taken in upstream will be T1, which is 12 by x minus y hours. So 12 is the distance traveled and x minus y is a speed. So same way, time taken in downstream, what happens? It is 40 km downstream and the speed is x plus y. So according to the formula, time is equal to distance by speed. So therefore what happens? T2 becomes 40 by x plus y. We know that the total time taken in this case is 8 hours. That means total time means it is T1 plus T2 is equal to 8 hours. So T1 and T2s are replaced as 12 by x minus y plus 40 by x plus y is equal to 8. It is our first case and it is going to be our first equation. In the second case, as you can see here, it is 16 km upstream and 32 km downstream in the same time. Same time is again here also it is taking 8 hours. So we already know in the case 1 that time taken in upstream is T1. Here it becomes 16 by x minus y hours, whereas time taken in downstream will be 32 by x plus y hours. So total time is 8 hours as it is told as same time. So T1 plus T2 becomes 8 hours. Replace it, it becomes 16 by x minus y plus 32 by x plus y is equal to 8. It is going to be our equation 2. So we have to solve these two equations. So far when you see this equation, it looks like a reducible equation. So regarding reducible equation, we have already studied in our previous video. You can just go through with that video which is already given in the description below. So let us start with that. So these are the equations what we got. So what we will do, we will replace 1 by x minus y as p and 1 by x plus y as q. So when you replace this in the equation 1 becomes 12p plus 40q is equal to 8 and 16p plus 32q is equals to 8. As you can see, both the equations coefficients can be reducible. That means we can divide these coefficients by 4 as well as 8 to reduce the size of the coefficients. So when we do so, the equation reduces to what? 3p plus 10q is equal to 2 because I am dividing first equation by 4 and the second equation by 8. So which reduces to 2p plus 4q is equals to 1, which is going to be my second equation. Now here you can see the reducing is very much useful because of reducing, when we go for any method, we will get a smaller number for calculation. If you don't reduce, dealing with the bigger number while finding the variables will be difficult. So whenever you find where you can reduce the equation, you can reduce it. But make sure one thing, entire equation should be divided by only one number. You cannot divide one equation with two different numbers. So now we are going to find the values of p and q. To p and q, I am going to follow an elimination method where I am going to cancel the variable p. To cancel variable p, I am going to multiply equation 1 by 2 and equation 2 by 3. By doing this, what happens? The coefficients of p become same. Then I can easily go for cancellation. So let me multiply it first. So when I multiply, I am going to get equation as 6p plus 20q is equals to 4 and 6p plus 12q is equal to 3, which are our equation 3 and 4. Now as you can see here, the coefficients of p are same and the signs also same. Since they are having a same sign, to cancel these two 6p's, I am going to subtract the equation. So equation 3 minus equation 4. Make sure when you are subtracting equation, you are going to change the sign. So now you can easily cancel 6p and 6p. So when you subtract 20q and 12q, you are going to get 8q. 8q is equals to 1. So q is 1 by 8. We already know that q is 1 by x plus y. So now we found the value as 1 by 8. That means x plus y becomes 8. Now let us find the value of p. That means I am going to substitute q is equal to 1 by 8 in equation number 4. Because equation number 4 looks much better than equation number 3. But you can choose any one of this equation. But here I have chosen equation number 4. So let us substitute. So this is what the calculation goes on. because we have already done this kind of a calculation. In the first step, I cancelled 12 and 1 by 8, where I got 6p plus 3 by 2 is equal to 3. Then I transposed 3 by 2 to the other side. It becomes 3 minus 3 by 2. Further simplification will give us p is equals to 1 by 4. We know that p we have taken this as 1 by x minus y, now which is equals to 1 by 4. That means x minus y is equal to 4. Now our new equations are x plus y is equal to 8 and x minus y is equal to 4. Now again, if you apply elimination method and you solve the equation, you will get the values of x and y as 6 and 2. Make sure the value of x should be always greater than the value of y, because the speed of the boat should be greater than the speed of the stream. Then only boat can travel in the upstream. So write the final statement, that is speed of boat in still water 6 km per hour and speed of the stream is 2 km per hour. Thank you.